Hello friends, you are watching channel Number Collage. Through this channel, we take sincere efforts to make you understand and like mathematics, science and engineering in a simple and easy manner. In this video, we will understand about the concept of friction. A wooden block is kept on a horizontal surface. Its weight W acts vertically downwards. A normal reaction N by the surface acts vertically upwards. The block is stationary as there is no external force on it. Now to move the block towards right, we have to apply an external force P on the block. When P is very small, the block will not move because of a resisting force F. There will be a resisting force F between the surfaces of this block and this surface. This resisting force comes into play because of the minute projecting particles of the bottom surface of this block and the top surface of this plane surface. This resisting force F is known as frictional force. As we increase the external force P from 0 onwards, the frictional force F also increases. Becomes maximum when the block is on the verge of motion. This maximum force of friction is known as the limiting force of friction or static friction F. As the external force P further increases, overcomes the limiting force of friction, the block is set in motion. The frictional force F now decreases. This reduced force of friction is known as dynamic friction. It has been experimentally found that static friction F is directly proportional to, so this is the static friction, the normal reaction N. So we write F alpha N, that is F equals mu N, where mu is a constant of proportionality. We write mu equals F divided by N, where mu is known as coefficient of friction. At the contact surface, F and N can be combined graphically. This is F, force of friction, and normal reaction N to get the reaction R. So this is the reaction R. R acts at an angle theta with N. This is angle theta. Theta is called angle of friction, which is given as tan theta equals F divided by N. Tan theta is F divided by N. So theta is tan inverse F divided by N. Normal reaction N is constant because weight of the block W is constant. So N will be constant. As P increases, theta also increases. It reaches a maximum value alpha. Theta becomes alpha. Alpha is known as the angle of limiting friction when the block is just about starts moving, like this. At this moment, we have tan alpha equals F divided by N, or alpha equals tan inverse F divided by N, but F divided by N is mu, which is coefficient of friction. So we have angle of limiting friction alpha equals tan inverse of mu, that is coefficient of friction. Let us understand an inclined plane. It is a plane surface that makes a definite angle with the horizontal and is especially used for lifting machines. In our discussion, we will draw an inclined plane. We will use inclined plane to understand angle of repose. Now, a block is kept at the edge of the inclined plane, like this. When the inclination is small, the block remains stationary. So this is the inclination. When it is smaller, the block remains stationary. As we slowly increase the inclination, like this, a stage is reached when the block starts sliding down. If we further increase the inclination, a stage is reached when the block starts sliding down. This angle of inclination for which, so this is the angle of inclination for which the block starts sliding down, is known as the angle of repose, phi. So this is the angle of repose, phi. On this inclined plane, there is a block and it is on the verge of sliding down. So the angle of the inclined plane is angle of repose, phi. Weight W of the block acts vertically downwards, like this. Normal reaction N, which will be W cos phi, is perpendicular to the inclined plane. Perpendicular to the inclined plane. Frictional force F equals W sin phi is along the inclined plane and in the direction opposite to the sliding motion. The sliding motion is in this direction, so the frictional force will be opposite to that. Coefficient of friction mu is F divided by N. F is W sin phi. N is W cos psi. So we get tan phi. Since the block is on the verge of sliding down, so we have tan phi equals tan alpha, which is coefficient of friction, which implies phi equals alpha, the limiting angle of repose. So we conclude that angle of repose equals limiting angle of repose. A block of weight 340 Newton is kept on a horizontal plane like this. It can be just moved by a horizontal force of 130 Newton towards right. So this is P 130 Newton towards right. This force causes this block to move just about so that a force of friction in the reverse direction, that is towards left, comes into play. This is the force of friction F. We have to find the coefficient of friction, magnitude and direction of the resultant force R. Weight of the block W gives rise to a normal reaction N, in the upward direction, like this. In equilibrium, sum of vertical forces equals 0. So n minus w equals 0. N is positive because it is upwards. W is negative because it is downwards. So N equals W, which is 340 Newton. So the normal reaction N is 340 Newton. When sum of horizontal forces equals 0, we have P minus F equals 0. P is positive because it acts towards right. F is negative because it acts towards left. F equals P equals 130 Newton. So mu n equals F, which is 130 Newton. So we have mu equals F divided by N. That is, coefficient of friction mu is 130 divided by 340. F is 130, N is 340, which is 0.38. So coefficient of friction here is 0.38. From the figure, we have R equals under root n squared plus f squared. So this is R. N is 340 and f is 130. So we get under root 340 squared plus 130 squared, that is 364 Newton. So we have resultant force R equals 364 Newton. Angle of limiting friction alpha is tan inverse mu, that is tan inverse 0.38, because we have coefficient of friction mu 0.38, which becomes 20.80 degrees. So R, that is resultant, is directed at 20.80 degrees to the vertical. A block of weight 260 Newton lies on a surface like this, whose coefficient of friction is 0.42. We have to find the limiting force of friction F, normal reaction N, resultant reaction R, and the angle of friction alpha. Now, weight of the block W gives rise to a normal reaction N in the upward direction, like this. In equilibrium, we have sum of vertical forces equals 0. So N minus W equals 0. N is upwards, so it is positive. W is downwards, so it is negative. N equals W, which is 260 Newton. So the normal reaction N is 260 Newton. From the values of N and mu, we will find force of friction, which is F equals mu N, that is 0.42 multiplied by 260, which becomes 109.20 Newton. So force of friction is 109.20 Newton. Next we will find R from the values of F and N. So it will be this vector R. From the Pythagoras theorem, we get R equals under root n squared plus f squared, which will be 282 Newton. So we get the resultant force R equals 282.282 Newton. So our resultant force is 282 Newton. Angle of limiting friction is given as alpha equals tan inverse of mu, which is coefficient of friction. So we have alpha equals tan inverse of 0.42, which will be 20.80 degrees. So the direction of the resultant force is alpha 20.80 degrees with the vertical. So this is about the concept of friction and some basic problems on friction. In the next video, you will get to see more problems on friction. If you like this video, please subscribe this channel by pressing the subscribe button. Thanks for watching. Have a nice day.